Thanks for coming. Let's get going. I only have 45 minutes, so I have to hurry up. This talk is about test-driven development in Drupal 8, and it's not about validating your code or making your client happy. It's also about using tests to make your code better. So my name is Teun. Don't try to pronounce it. You can call me Antonio if you prefer that. And on IRC, I'm never on it, but when I am, I'm called Nueth. I'm a freelance Drupal consultant. I work basically for people everywhere in the world. And my Twitter nick is NuethWeb. So this presentation is about test-driven development, and for that I'm going to use an example module that I built for the purpose. I built it also just to figure out myself how test-driven development works in Drupal 8. It can be helpful if you have your laptop to click on this link, or one of the two links. One is the long version and one is the short version. It's the Git repository. You don't have to do it. You will be able to follow all this without it. Maybe after the presentation you can click on it and check it out. But I will be using examples from this module. So why would we test? As I said before, you want to test to validate your code, to make your clients happy so that the client knows that everything is working. But you also want to test because it helps you writing your code. In Drupal 8, we have a great, amazing set of tools to test. In comparison to Drupal 7, it's much better, much easier to implement, and we have more options to test. So I don't know if you remember simple test in Drupal 7. That's basically a functional test, so it's testing user interaction, browser interaction. So the equivalent in Drupal 8 would be the browser test. Those are functional tests. And they require a full installation of Drupal. In Drupal 8, we also have the kernel test. The kernel test is not a full installation of Drupal. It's not meant for testing interaction with the browser, like checking if things exist on the screen, but it's meant to check whether all your classes and methods work well together. And then, on the most abstract level, we have unit tests, and we use PHP unit for that. And unit tests are basically the testing of a very specific method of a very specific class without actually testing its relationship to other classes and methods. And then on the other end of the spectrum, we have the JavaScript test base, which is basically the same as the browser test base, but added the option to test JavaScript functionality. So how do these tests work? The unit test doesn't require any Drupal. You don't need Drupal to the unit test. It's just purely PHP. You need a library called PHP unit, which comes with Drupal, so you don't have to install that. It will be there. But you're not bootstrapping Drupal. You're not installing Drupal. Kernel test, you install a partial version of Drupal. You install some of the tables, the database tables you need, but you don't install the whole version of Drupal. For browser and JavaScript tests, you do install a full version of Drupal, which is required to actually test the output that's been printed on the screen. So you can imagine that the difference in speed is massive. Unit tests are incredibly fast. You don't need a database, you don't need anything, you don't need caches, whatever. It's just that specific method that you're testing. So that's super fast. Kernel test is obviously not that fast because you do have to install bits and pieces of your Drupal installation, and browser and JavaScript tests are just really slow because you need to install. You can imagine when you do manually install a Drupal, well, for every test you run, browser tests and JavaScript tests, you need to install the full Drupal. It's a very minimalistic version of Drupal. It doesn't have bartik unless you want it. It doesn't have lots of modules enabled, but it does install and bootstrap the full version of Drupal in a minimalistic version. So the good thing about testing in Drupal 8 is that it's increasingly using industry standards, stuff that other sane people that are not Drupal people, but normal people use too. So that's good, you know. That means that we can work together with other people that are used to this type of stuff. PHP unit is the basis of all these tests, also the JavaScript test, but the JavaScript test extends the browser test. That's why the arrows only go to the first three, but in fact the JavaScript test is also implementing PHP unit. And the browser test on top of that whole thing is also implementing Mink, which is a sort of a hidden browser that allows you to, through code, click on buttons, check if forms are filled in, and checking if stuff is, you know, visible on the website. Phantom.js is used for the JavaScript test base. Phantom.js is a library that allows you to test stuff that is going on in JavaScript level for the time being, because Phantom.js has stopped receiving maintenance, so that will probably be replaced in the future by something else. So how can I do this? How do I start with testing in Drupal 8? Well, it's really easy. I have to compliment all the people that built this. I wish I was it. I didn't. It's really simple. You go to the folder core in your Drupal installation. You copy the file phpunit dist.xml to phpunit.xml. You fill in the gaps. It's a file like settings.php that you just fill in the gaps, database connection, another couple of things. And when you have that file, you just run in your terminal vendor bin PHP unit. If you run it like that, you will run all of Drupal 8's tests. So it will take a while before it's finished. But this is basically the whole thing. You can also use PHP Storm to run your tests. It's sometimes easier. You'll see that in an example later on. So where do these tests go? If you have a Drupal module, basically you mirror your files that you have in your src directory, where you have all your functionality, your controllers, your new entities. And for unit test, you put them in a folder called unit, kernel, functional, and JavaScript. And for example, if you have a folder called entity for your custom created entities, they would go, for example, if you want to unit test them, they would go into unit/entity/myEntityTest. So there's just these things. They are sort of random. I put them in here because if you know them before you start doing this, you'll probably save yourself a couple of days figuring out what's going wrong. They're really simple things, like part of testing is debugging, is putting in breakpoints in your code and stopping it where you want it to stop. If you want to use PHP Storm's debug listener, you need to enable the xdebug remote auto start feature, which will catch any of those connections. It's not enabled by default. If you enable it, it will work out of the box. So it's technically not out of the box, but with this on, it will be out of the box. Then there's another setting that is very useful to know. That is the maximum simultaneous connections. Its default value is 1, meaning that every AJAX call or every second request will not be picked up by xdebug. And AJAX, as you know, is like a second request on top of the original HTTP request. So you need to make sure that this is not 1, but 2 or 3 or 4 or 5. Put it on 5, for example. So that's just a little couple of hints to get you going. To get xdebug going with your test, while you're running your test, this will all become more clear after I've shown you a couple of examples. You just click that little phone, and then it will pick up all the xdebug connections. This is in PHP Storm. If you're not using PHP Storm and you're not like a Vim-savvy tech geek, then I would definitely recommend PHP Storm because it's very easy. So let's go. Because what we're trying to do is build a module. The module that I showed you in the beginning. You obviously don't know what this module is going to do. Well, it's going to be a game. It's going to be Connect 4. Conecta cuatro in Spanish. So it's a very simple game. You have one home user, one away user, and one game. The away user, the home user puts in the red disks, and the away user puts in the yellow disks. And whoever gets to 4 in one line, whether or not it's diagonal, horizontal, or vertical, wins the game. So this is a fairly easy game that even I can build, you know? So that's why I chose it. So well, you can't see this is supposed to be a table, so there should be lines visible there. But basically, this is like the bar tick version of my game. It's a table with on the top row, in the T-head section of the HTML, there's some play buttons, and when you play, it should drop the disk to the level where there's a gap and show that, you know, that's a red disk or a yellow disk. So this is what I want to build. So let's get going. The game, there's not enough time to really go into details about how this game is built, but basically there are 3 content entities. A move, that's my own content entity. That is the moment that you put the disk in. It will have an X coordinate, a Y coordinate. It will have the user that played it. Then there will be a game content entity, which is basically you can't play in different games at the same time. You can only play one game at the same time, and the moves that were played belong to a specific game. And then the user is the default core user content entity that will be attached to the move, so we know who actually played that specific move. All the functionality will go into our Connect for service. So this is a little bit of context so you understand what's going on here. So let's start with a browser test. Browser tests are really the easiest. Why? Because you just say, when I click this button, what happens? Or when I go to this URL, what do I see? The syntax is incredibly simple. If you use PHP Storm, it will autocomplete your methods, so you will see all kinds of methods that appear. And we'll make it very, very easy to build this. So Connect for functional test extends browser test. That's our test. First, we have to fill in a modules static parameter, which is an array of all the modules that you want to enable. This is also the same for kernel tests. Then there's a method called setup. This goes for all of the tests, and setup is a method that you can use to kind of set up all your tests that go in one class. This means that for every test you built in one class, in one test class, this setup method will always be used. So you don't have to duplicate code. If you are going to use a home user and an away user, as you can see on the next slide, you need those home users and away users for every single test you're going to run. So you put them in the setup, and they will be there for you to use every test that you run. So the home user, I'm going to use a Drupal create user method that comes with browser test to create it. Very simple. Away user, the same thing. And the game is calling the static method on my game content entity, and then save it. So let's write the test. The test itself always starts with the word test, and then the description of what the test does. So in this case, I want to test whether or not I see buttons on the screen. Do I see the button play? As a home user, I log in, I'm first, it's my turn first, so I should be able to see those play buttons. As an away user, I log in, and I shouldn't see them because I would be playing before my turn, so I shouldn't be able to see those play buttons. So let's test this. You log in with the method Drupal login with your home user, you go to the path that I've defined where this game will reside, and I just call the assert session button exists play. So if this fails, if there is no play button visible, then my test will fail. Then I will click the first available play button, and then obviously the page will reload, and it should not show the play button again because it's not my turn anymore. It will be the turn of the away user. So I'm checking button not exists play. Then I'm logging in as the away user, I'm going to the same page, and then I should see, since it's now the away user's turn, I should see the play button. So let's see this in a little video. I have to warn you that this is quite a quick video. Thanks. It's quite a quick video. This will go pretty fast, but basically what I want to show here is that browser test uses Mink, and Mink will generate for every HTTP request an HTML, a static HTML file of what you would have seen if you were manually doing the test. So let's play this video. So here you see the test method, test C buttons, and I'm going to run the test in the terminal, which is PHP vendor bin PHP unit with a couple of filters, so I make sure that it's only running the C test button. As you can see, it generates the HTML files, that's the list at the bottom. It has 9 assertions, and they've all passed. And when I go to those HTML files, that's with some extra information, I see what the Mink browser has seen. So it's logging in, going to the home user, it's going to the Connect 4 page, it's clicking the button play, and it will then not stop showing the play buttons, it's a second page load. It will show the disk that has been played. Now I'm logging in as the away user, and seeing the page of the away user, and then I can't see the play buttons at the top. So that was the browser test. So let's check out the kernel test. Kernel tests are specifically useful. How many times, can I ask a question to the audience? How many times have you written an application and then printed on purpose stuff to the browser just to check if everything was working? Hands up, who's done that? Pretty much everyone, yeah. Well, not everyone's hand went up, but I don't believe you if you didn't. Basically, that's time-consuming and not necessary. What you want is you want to use tests, those moments that you feel, I'm going to print this to screen, see if it's working. Stop doing that, write a test. That's basically the idea. So let's write a kernel test for this specific method. And I'm going to tell you in advance that this is not really the right approach, because what I want to be testing with the kernel test is how different methods and different parts of your Drupal applications communicate. But for the purpose of making this a little bit simpler, I'm just going to test one specific method with the kernel test. And the method I'm going to test is get maximum moves inline, which is the method that is going to figure out, after having played the last move, how many moves there are in one line, diagonally, horizontally, vertically. So it's going to test, this is my last move, it's going to see if there's 4 in one line, for example, in this case. So I'm going to set up my module. As you can see, there's a modules argument again and a setup an argument, but in case of the kernel test, we're not installing a full Drupal, so you will have to install the tables that we need. We'll have to install the table that comes with my custom entity, and for that I can use my install entity schema. We're going to install the system module, and the system module requires the table sequences. Please don't ask me afterwards why, I don't know. But if anyone knows, I would love to hear it. It's Drupal core stuff that is difficult. So that's the setup method. I've installed my Connect 4 move table that I need to save my moves. I've installed my Connect 4 game to save my game. I've installed the user table to save my users. And I've installed the system table sequences, of which I don't know the purpose. What I want in this test, and in general that should go for every test, is that you want to test with real data. You want to think of scenarios. You want to think of what happens if I put in these moves or those moves. And so what you want to do is you want to put different scenarios through that function, and we can use a data provider for that. And a data provider is simply another method in the same test class that will get an array of data which you can fire at your test method. So in this case, what we're going to do is we're going to put some data of which we know the outcome, and that data will be in a YAML file, and we're going to return it as an array. So the YAML file is basically just a list of moves. Move 1 has x coordinate 4 and y coordinate 6, and is played by user 1. Well, like that, you create a YAML file with real testing data. Also, what we're going to put in this YAML file is the expected outcome, because we put in that data, we know how many of the moves are in one line. We know that because we figured it out on pen and paper. So in this particular case, we know that there's going to be 5 in one line, for example. So how do we make sure that our test method works with that test data? That's basically by adding a annotation called data provider, indicating the function that is going to feed your method. And from then on, that method will run the amount of times there is data in your array. So in our case, in the YAML file, as you will see when you open the GitHub repository, you will see that the YAML file contains 3 scenarios. So this 3 sets of data, so this specific function will run 3 times. So the data will have the x and the y coordinates and the user that played it, so I'm going to create move entities accordingly. I'm going to create them with my static create method, I'm going to save them, and I'm going to add them to an array of moves. And then I'm going to call my function that I'm actually going to build, which is not yet built. It's completely empty, it doesn't do anything, but I know that if I pass on the last played move to my method, it should return an array of moves that go in one line. That is that's my objective. That's what I want to achieve here. So, as you can see here, I'm calling my method that I'm going to build, and I'm going to assert that the expected outcome that is in my YAML file is the same as the sum of the elements that's in the array that this method should return. So let's see how this works in a video. So this is my test method. I'm going to create my moves according to the test data. And I will click on the moves data provider, which is my method that will give, that's on the bottom of the screen right now, that will turn my YAML file into an array and will pass it on. This is the YAML file, as you can see it here. Now I'm going back to the test. And as I told you before, what's very useful here is to put some breakpoints in here. Use xdebug, so it will stop when I'm executing this code. Then I'm going to the method that I'm going to write. And as you can see there where the mouse is, I don't know if you can see it, but basically I have an empty array because I haven't filled in this method yet. This is completely empty. It's just returning an empty array. So if I run this test now, and I'm running it from PHP Storm, it will fail. It will first stop at the breakpoint, but then I'll let it run. You see here at the bottom that I'm getting the data from my YAML file. It will run, and it will fail because the array is turning an empty, or the function is turning an empty array, but I'm expecting an array of 5 elements or of 3 elements. So my debugger or my test tool in PHP Storm will tell me that this is failing. It will turn red. Let's see if it does that. Here you see it at the right. We'll see that all tests have failed. It will say expected is 3, actual is 0. I can click on see the differences to compare them. Obviously, this is a very simple example, but you can test it with big arrays of data. And obviously, I've written this method already. It's in Git, so I'm going to put this method in it, and I'm going to run the test again. And you will then see that all the tests pass. Obviously, it's beyond the scope and the time to really explain how this test is built. I invite you all to look at the code. But what I'm trying to explain here is that I didn't have to go to any browser. I didn't have to print anything to the screen. I know that my method is working. Just by staying in my IDE, staying in PHP Storm, I don't have to go anywhere. So let's go to the unit tests. Now, the unit tests are probably the easiest and at the same time the most difficult thing to understand. The unit test is very simple because it's only testing the method. As you've seen before, I can ask myself the question, am I testing a specific method? What should I do? Build a unit test, which I didn't do in the last, in the kernel test, just because it makes it easier to explain, but I should have built a unit test. But there's one big problem with unit test. Unit test doesn't bootstrap, doesn't install Drupal. I can't save my moves that were in the YAML file. I can't save them to database. There is no database. There's nothing. There's no caching layer. There's nothing. So what I need to do in order for me to test this method, which I know will take a move as an argument, I will need to mock those moves. I need to mock everything that I need to pass on to my method, make it think that I'm using a real move entity, and let it work with that. Now, mocking is a very difficult concept to understand, but I think I found the perfect example to explain it, and that's a crash test dummy. Think of testing a car. When you test a car with a real human being, there will be blood, there will be a funeral, there will be quite a bit of cleaning involved. In other words, a real human has methods and behaviors that I don't need. So let's take a fake human, a crash test dummy, that will have some of the behaviors that I need. It will move its body in the same way as a real human, but it won't shed blood. We won't need to organize a funeral for it. So it's a lot easier to test with a crash test dummy. Now, a mock object is a crash test dummy. What a crash test dummy is for a car, a mock object is for our unit tests. So whenever you think, what is a mock object, just think of this crash test dummy. It's the same thing. So let's compare the two. I'm writing a real move, and I'm saving it to the real database, as we've seen in the kernel test. So I'm calling my static methods on my move entity. I'm going to pass on the x-coordinate from my YAML file, the y-coordinate from my YAML file, and the user ID from my YAML file. I'm going to save it, and then when I call the getOwner method, which will return the user object, and then on that user object, the ID method, I will get an ID of the user that owns this particular move. Now let's see how we would write this in a mocking way. For this, I prefer using the prophecy library. There's several options. I recommend everyone to forget about all of them and just use prophecy, which is by far the easiest. A prophecy, it's a bit of a confusing term, so don't think too much about why it's called prophecy, but basically you have a method called prophesize, you pass on the move class, uninstantiated, and then you say, if getX is called, return this value. Don't go looking into the database. Don't go crawling through caches or whatever. Just return my X value that's in my YAML file. Same goes for getY. But what if I, for example, want to return the owner? Well, I can mock the owner too. I can see the owner is an account, prophesize the account interface class. And then when ID is called on that particular entity, which is a mock object of my real user, then I should, instead of going to the database and collecting that ID, I should return just the YAML, the ID value that's in my YAML file with all the data. And when I then call getOwner on my move, it should return the mocked version of the user. How do I actually use these mock versions? I need to call, in the end, when I start using it, I need to call the method reveal. This is just syntax. This is the way it works. But at the end, if I call move getOwner ID, the result will be exactly the same as in the first example, which will connect to the database. So a really quick video. I've rewritten my test, my kernel test, to a unit test, and instead of using real move entities and real game entities, real user entities, I'm using mock versions. And I'm not going to blow up this screen. It's only to show that it literally takes like less than half a second to run 3 tests. It's a lot faster because you're not installing any of Drupal. So last test I want to discuss is the JavaScript test. As you can imagine, if the away user logs in and it's not his turn, then he will be waiting until the home user has made his play, that he has played his disk. So the away user is logged in, he doesn't know when that happens. He would have to click on refresh every time, every second, for example, to check if the home user has played the move. So in this particular example, I'm going to test what if we constantly check with the server if the home user has made his play, and if so, automatically refresh it. So basically, what you see here is still a browser test. This is still, I'm calling the method on my Connect4 service to play the home user's move. What I really want to show is the method wait for button. There's loads of methods. There's loads of difficult ways to test JavaScript. This is one example of a JavaScript test method. It's wait for button. It will wait until the AJAX call has been made to show the button on the screen for the away user. I think this will all be much clearer when we actually play the game at the end. The really good advantage of Phantom.js that we use in the JavaScript test base is Mink will save the HTML files, static HTML files of every HTTP request that has been made. Now, when you call an AJAX call, there is no HTTP request. At least there is an HTTP request, but it's not really about user interaction. I don't know exactly how to explain this, but what you can do with Phantom.js is to save a print screen. So after the AJAX call has been made, you can print really what you would see, a print screen, a JPEG file of what you would see. So a quick video, I won't blow this up, it's just to get an idea. For Phantom.js, I have to run Phantom.js separately, apart from running the test. And I'm going to run the test in the terminal. Unfortunately, PHP Storm is not able to run the Phantom.js test fully. Doesn't know how to print HTML files to files because of a bug. There is an issue for that. But basically, I'm going through the same Mink HTML files, but I also have a print screen. And this print screen appears after the AJAX call has been made. So I think this is, considering the time, I've went over this particular JavaScript test case quite quickly. But let's just play the game. Not that click. Yeah. So let's play the game. Just before I play the game, and it will all become clear what we've tried to do here, I just want to go over why you would test. You have unit test, kernel test, browser test, JavaScript test, and your objectives with testing are always write better code, get a better experience as a developer, create an application that is more stable, and to have just happier clients. But if you look at the different types of test, you can see that the unit test will immediately lead to better code. Why? Because you're forced to keep your methods small, because if your methods are very long, that you have to mock everything that's going in it, it's immediately a big mess. If you use unit test, you're forced to keep your methods small and concise, so your code will be better. Now with kernel test, I think since mocking is quite a difficult thing and sometimes a bit of a hassle, the kernel tests are really giving you a better experience as a developer. You don't have to print stuff to the browser, so that's why I said, okay, that's a really big advantage. And then the browser and JavaScript tests are more about behavior-driven development. They don't mean that your code is going to be good. You can implement a browser test base and write absolute, shite code in the backend, and your browser test will still pass. So in the browser and JavaScript test, there's also lots of alternatives, and I recommend everyone to go to Jorge Tutor's talk tomorrow at 9, which will be also about implementing other libraries for the browser, the functional tests. So let's play our game. So I can see on the left, I see the home user logged in, and on the right, there's a away user logged in, and I've tested everything, so this shouldn't fail. So I can play now. There should be a constant polling going on. So the other side, it's not using WebSockets or anything fancy, it's just using HTTP requests. But the other side of the screen will update because it will know now it's my turn. So this is basically the game. And now let's see if I can finish it as quickly as I can. Because in the last in the practice session I did here in Madrid, it took me about half an hour to finish this game. So I've actually practiced finishing this game in a timely fashion. So, well, that's it. If anyone wants to fill in the gaps here to the left, but basically the right one is the winner. Okay, well, let's see. Basically, that is it. Now, I now know that I'm never going to use the Google widget for asking questions anymore because nobody used it. Does anyone have questions? Yeah, I can see.
You mentioned that Phantom.js is not supported anymore, is not maintained by anyone.
Yeah, that's true. The official maintainer has announced that he thinks that headless Chrome is going to be the future, and he doesn't see a future for his own library, meaning that at some point Drupal will have to go over to some other solution, maybe Selenium or headless Chrome or...
I wanted to ask about alternatives. You just answered.
Okay.
Okay.
So I should have repeated that question. He was asking about Phantom.js not being supported anymore, and I was explaining about the fact that it's not being maintained anymore because the maintainer thinks that headless Chrome is the more relevant solution right now. Anyone else? Nope. Okay.